Hey there, let me talk to you about Strange Loops. It's a design tool that I've been working on in my spare time. I'm a professional game designer, I work in the games industry, and I'm always on the lookout for like small, different, weird tools out there. And this is one of my own. It's a tool for game designers, and it basically is an interactive state machine. So yeah, let me run you through it. So when you first come to it, I'll leave the link in the description. By the way, it's on my GitHub page, so the code is open source. Feel free to fork this or modify it to whatever your needs are. But when you come to it, I have this example here by default, which is sort of a progression diagram of Hollow Knight. Hopefully it's not too spoilery. I think if you've never played the game, this is going to be abstract enough anyway. You probably wouldn't really be able to glean that much information from it. It only really makes sense in the context of you sort of knowing what the game is about. So this is a progression diagram where you've got all the different areas and sort of the links between areas sort of are the requirements the player would need to be able to traverse from one area to another. But the nice thing about this is it's not just a diagram, it's an interactive diagram. So I can hit any of these sort of play buttons and it will drop me into sort of simulating, okay, the player's in this area. It will highlight all the areas that I can now traverse to, so I can sort of come over to here, and now it's traversing down to here. And then, yeah, that's basically what this is. Think of it like an interactive state machine, or for the more maths nerds out there, it's also kind of like a Markov chain. But we're not going to look at this example. What I'm going to do is, let me just stop that. I'm going to come to File down here, and we're going to start completely from scratch, so I can better explain, you know, what this tool is about, and why you might want to use it. So what we're going to do is we're going to do some sort of gameplay loop of a generic shooter game. So the first thing you want to do, in order to create any sort of state of your game, state of your simulation, whatever it is, just double click on the graph anywhere. When you double click, you get one of these nodes. And so we're just going to block out a very simple sort of gameplay loop. So with this selected, you know, this is where we start the game, and then maybe the player enters a level, right? And then they'll explore the level. Now, if you want to sort of create an edge, as a mathy sort of term for graphs, or a line between these two sort of states, if you just hold Alt, you'll get this crosshair, and then you can just click and drag over, and now I've got this directional edge from start game to enter level. Edges are directional, so because the arrow is pointing this way, we can go from this state to this state, but we cannot go back from this state to this state. So if I hit play, I can come over to enter level, but you can see now this is not green, I cannot go back to start game. However, if I also add the edge going the opposite way, I can sort of jump between those like that. So we'll leave it like that. So enter level. Another sort of quality of life thing is you can hold Alt, you can drag off and just release in an empty graph, and it also makes a node for you. So, you know, the player might explore the level for a bit, and then they might encounter sort of combat, encounter enemies, right? And then, okay, this might be where we diverge. So we encounter enemies, maybe we kill the enemies, and then we get loot, right? Let's say claim loot. Alternatively, you know, the player might fail and be killed, right? They die. And then when the player dies, let's say they go all the way back to the start of the level. Okay, so we're starting to get the gameplay loop. And so they claim loot, and then let's say a level is made up of multiple areas. Maybe each level has 3 distinct areas that you traverse between. So this one, you complete this area, and then you move to the next area. and then you sort of come back and explore the next area. And so we got sort of this little loop, sub-loop going on around here. And so, yeah, it's already shaping up as a nice sort of diagramming tool, but these already exist, you know, there's plenty of diagramming tools out there, Miro, Microsoft Visio, TL Draw, that kind of thing. I guess the nice thing is this is just a sort of a single page web app. You can download this, you can run this locally. There's no sort of server or cloud component to this, which is nice. You can just download files straight to your computer. Keeps everything nice and sort of local and secure. But this interactive element is quite nice, right? And you can imagine as your gameplay loops start getting a bit more fleshed out and bigger, it is nice to just sort of just be able to like mentally walk through the steps. But we can do so much more than just that. Let's say we want to keep track of these 3 areas. That's where we get into a little bit of scripting, right? If you click any of these nodes, obviously you can add a description, and that, you know, updates there as you type that. But you also have a script you can run, and this lets us do certain logic whenever we sort of enter this state. If you're ever confused about anything, you can hover over. I've got sort of help on a lot of this stuff. If you just click on the background, you get this, and you can see what is this. It'll explain some of the hotkeys. You can click on any of the nodes, and you can explain sort of how the scripting works. You can click on an edge, and even edges can have scripts, right? I've tried to sort of document everything in place where I can. But yeah, let's do a bit of scripting. So we want to keep track of how many areas in the level we're traveling from. So every time we complete an area, we sort of want to increment a number to say how many areas we have completed. So I'm gonna click on this complete area state. I'm going to come up to the script, and I'm going to type in the following: g dot areas completed plus equals 1. Okay, so let me just quickly break down what's going on there. By prefixing this with a g dot, we're saying this lives in a global namespace. Every node has 2 namespaces you can work with. You can work with the global namespace, which means the variable will pop up in the side panel wherever you are. Let me demonstrate that. I click complete area, and now you can see over here in the side panel it's saying areas completed 1. So that's what happens when you use G. The G stands for global. Alternatively, we could have written self dot areas completed, and when I run that, it just stores that information on itself, this node that I've attached the script to, right? And the difference there is if I now come to like a different node, say enter level, when I do self.areas completed, well, the enter level is its own node, so it doesn't have access to the same sort of data of this complete area node. So this is almost an entirely different instance of that data, whereas had I stored it under the global namespace, I could access that information from any other node and do stuff with that. So that's what we're going to do here. I'm going to come stop all that. So areas complete area, areas completed plus equals 1. We're going to say every time you enter a level, we're going to say areas completed equals 0. So every time we start a new level, each level will have 3 areas you can complete. And here's where we can do some fun logic. So we're going to come off complete area, and we're going to create another node, which is complete level. So we can only access this once we have completed 3 areas. And the way that works is I can click on this edge going from complete area to complete level, and I can do what's called a wait script. So if you're familiar with graph theory or Markov chains, usually you have nodes, and nodes are connected by edges, and those edges have weights. By default, an edge has a weight of 1, which means, to give you another example, let's say we're in this encounter enemies node, right? There are 2 edges leading out of this node, and they both have a weight of 1. And what that is establishing is that they both have an equal likelihood of being traveled across. And you can actually do this in the simulation. If I click play here, you then get this little die button, rolling a die. And when you do that, it will randomly pick one of these valid edges to travel across. And the way it picks that is dependent on the weight. And because they're both 1, they're both as equally likely to be picked. And it's picked for me to die there. Whereas, say I wanted die to not be as likely, and you're much more likely to survive and claim loot, I can click on this edge, I can come up, the weight is currently hidden by my face. Let me scroll down. See, there's a weight number here. I could bump this up to 100. And now you'll see anything that's not just 1, I don't bother showing the number, but as soon as it's a non-default number, you'll see the 100's printed here, and if I roll the die, it's probably always going to take this route, and in very rare circumstances, it's going to take the die route. Now, what a wait script is useful for, let me actually give that a 1, and let me put my face back up here. Actually, no, let me put my face up here. It's probably a bit better. What that is good for is we can dynamically change what the weight is depending on our data that we're creating on the fly. So if I come down here, we only want to complete the level once we've completed 3 areas. So if I just go into this wait script and I do g.areas complete, is that what we call the variable? Oh, we did completed. And we want to check if that is equal to 3. If you're not familiar with programming, and this is just JavaScript, by the way, what you put in these boxes, just pure JavaScript, you do equals. Technically in JavaScript you would do 3 equals, but 2 is fine. And that's going to then, if this statement is true, this will boil down to a 1 and set the weight to 1. If it was false, it will boil down to a 0. And when a weight is 0, we're saying it's impossible to travel across that edge, is what 0 means in this case. And we can actually see that if we click this now, this edge is red, which we can't travel across it, and this edge is green with the default weight of 1. So we can only go over here. And as we loop around, we've completed 2 areas, which you can see down here. And finally, we've completed 3 areas, and now we can move down this way. And I think to complete this, we actually want to block off this path to the move to the next area, because we're not saying a level has 4 areas. So to do that, we come up, we click on this edge, come to the wait script, and we're going to do g.areas completed is less than 3. So we can only go across this edge if this statement here is true. Yes, so we've done that, and then once we've completed the level, we probably then will go all the way back to enter the next level. A little tip for keeping your graphs tidy is obviously this line sort of cutting through here. You can always double click on an edge, and I'll add a little reroute node here. If you're familiar with like Unreal blueprints or whatnot, it's a bit similar to that. So I'm just going to make things a little tidy like that. All right, nice. So what can we do now? So we can now simulate the game. Obviously we can come across. What would be nice is we've got the area down here. I want to make that a bit more obvious. So what I'm going to do is I'm going to press the button W while my cursor is in the graph somewhere, and that's going to create a watcher. And the watcher is just a nice way to sort of bring some data a bit clearer in the graph. So if I go up to the script in the watcher, if I do self dot areas completed equals the global areas completed, it is now going to appear on this. And the nice thing about these scripts is they run whenever any other script anywhere else runs, whereas in a state node, these only ever run when you get there. And an edge script typically only runs it depends on a setting, but they typically only run when an adjacent state node activates. So these are nice for just watching variables. So if I now come here, you can see this will update, and as I go around, it will sort of update with that information. So now we're making a bit of a nicer graph. And you can do, we go back to the level. Areas completed is now reset back to 0, and now we're in another level. So far, so good. Let's expand upon this then. What about loot? What is loot? Well, maybe loot is money. So let's do that. We'll click on the claim loot, and we'll do in the script, we'll do sort of g.money plus equals. Did I explain what plus equals is, by the way? All that's doing is it's incrementing that variable by a certain amount. So if I do 100, my money goes up by 100. I could do minus equals. If I did that, my money would go down by 100. I can do times equals. If I did that, my money would be multiplied by 100, whatever my money currently is. I haven't used money anywhere else in this graph, so this would just implicitly be 0. So I'll be multiplying 0 by 100. But let's say we get some money, and maybe it's random, right? And to do the randomness, you literally just do the word random, followed by a pair of parentheses. This is a function. So this will return a random number between 0 up to 1 and any sort of decimal number in between. So if we did that times 100, because this can go 0 to 1, so this now can be 0 to 100 and any decimal in between. And we can do that. We can do that, and we can see down here our money 31.74. What I actually like to do in this is take this random line and actually put this into a self. So I could do like money gain equals that, and then I will increment our actual money by this self.money gain, which means every time I claim loot, I can see, how much money I actually gained when I got there. I just find that kind of useful, and then we come again, it gives you another value, but you see our actual money wallet is sort of persisting on each loop and increasing. So that's all well and cool. So let's do that as well. We'll call this sort of info. We've got areas completed. We'll do self.money equals g.money. So that'll get updated there as well. How about health? So how can we do that? So maybe when you start the game, you start with a certain amount of health. Maybe you have like a max amount of health. So let's do that. We'll do g.max health. Maybe it starts at 100, and our actual player health will start off g.max health, right? And then when you encounter an enemy, you get hit, right? How much you get hit by? Well, let's say our g.health minus equals random. Just to demonstrate this, I'm going to do times 200. So there is a chance we get hit for more than our full health. So there's a chance we can die here. So we start game. Let's highlight this in this info g.health. Floor, boom, our health is 59 now. Come around. Our health is down to 10. So what we want to happen is if this goes below 0 at this point, okay, negative 75, so we're definitely dead. We want to block off this path and only allow us to go through the die path. And likewise, if we've got health, we can't go through die. So again, pretty simple. We set the weight to die to 1. So we do if g.health is less than or equal to 0, we are dead. And the same with claim loot, we want that to be g.health is greater than 0. If we're not dead, we can only go along that path. So if we restart this now, we can do that. You see this is red, we can't die yet. Come around, and now we're dead because our health has gone down. And now we have to go back this way. And then we come back to enter the level. The problem we have now is we need to reset our health. So we'll do this in sort of the... Tell you, let's delete this edge and let's add a new node called respawn. Right, so you die, you respawn, and you re-enter the level. And here I'll do g.health is equal to what our max health is, right? Just like what we did at the start of the game. And, you know, this is nice now because it's forcing us to think about the state of our game and sort of the order of operations of when we need to do certain things. Obviously, this is a very simplified example of a game. I'd argue you probably don't need a tool for such a simple case like this, but this is for more like as you get into larger and larger sort of spaces of exploring game design. It's, you know, like a pen and paper, it helps you if you sort of flesh that out. Cool, so we've done that. But we can expand on this further and further. Let's say we want to heal, right? So maybe enemies don't just drop money, they also drop health pack. But not always. Maybe there's like there's a 50% chance they drop a health pack. So what we can do, because remember, scripts are just JavaScript. So if you've got any familiarity with JavaScript, I recommend, if you're not familiar with JavaScript, there's so much material online to learn JavaScript. And also there's like games on Steam that are programming games that use JavaScript. It's a great way. Fortunately, none of them are coming to head. Yeah, I'll let you know if one comes to mind, but I'm going to do a check here. So actually, no, we're going to do self got health pack, and that's going to be equal to if a random number between 0 and 1 is less than 0.5. So that's a 50-50, right? Because it could be any number from 0 to 1. Half the time it's going to be below 0.5, the other half of the time it's going to be above 0.5. So that's how we do our 50-50 die roll. And then if self got health pack, we are going to say our health is going to increase. How much health? Say a health pack, it's got 50 health in it. Now we don't want to go over our maximum health. And so actually to do that, we're going to rewrite this g.health plus equals 50 a little bit. We're going to say g.health is equal to whichever of these is the smallest value, min g.health plus 50, comma, g.maxhealth, right? So this min function will pick either whichever of these two things separated by the comma is the smallest. So if g.health plus 50 goes over our max health, then it's going to pick max health instead, because that is our smallest. And then now we can actually start thinking about some game design, right? Is that enough health? I mean, probably not if we're just losing up to 200 hit points every time we encounter an enemy. Let's actually simulate this. So what I'm going to do, and this is a bit advanced, but I'm going to create a button. A button, unlike a state, you can just click these at any time. There's no state. They don't sort of connect via the graph. They're just a button you can press to run a script. And what we're going to do is we're going to sort of create an automated player, a player that just automatically moves around this graph, clicking the random die button each time. And the way to do that is we need to make this the start node. So we're going to do node.run and give it the name of our start node, which is this one. You can either give it the title you've put here. You also have this ID, this string of numbers, which we could use. The nice thing about using that is I could, if I rename this doesn't break. But we'll just keep with start game here. And then a comma, and then we need one more bit of text, and that's going to be what I call a thread, the name of a thread. Think of a thread like a player entering a game. So I'm going to call this player or thread auto run, because it's going to auto run through the nodes. So if I just hit this button, it's just going to run this node automatically for me. Again, if I ever want to get back to just a state where nothing's been activated, I click this button down here, stop all threads. And then I'm going to call another function called thread.autorun, and I'm going to pass in this name that I put as the second parameter to node.run. So that's autorun. Again, I mean, I could change this to Kevin, right? And then that means I would need to change this to Kevin. Let's use Kevin, right? And then it needs one more parameter, and that's the number of seconds in between each sort of step along this. So let's just do a second, right? If I now auto run, right, and I hit the button, every second it's going to come along and just run this simulation for me, which is great. And you can see, I went around once, I completed one area, and I died. And that's probably going to be the most likely thing each time, is I'm never really going to get past completing one area. And we can make this a little faster. Let's make it twice as fast, 1.5. Cool. All right, so that's clearly unfair. And I think this node here, encounter enemies, is a poor simulation of what is actually going on. So let's break off this graph and do like a subgraph, a more detailed graph of what it is to do combat. So let me just highlight. I'm holding shift click here, by the way, and dragging to create a box. And then I'm going to group all these together by pressing the button G. Right, and this is our core gameplay loop. When I'm going to come off to the side, and I'm going to do a more detailed graph of combat. So how does that work? Well, step one, you sort of encounter enemies. Step two, you attack enemies, right? And then maybe enemy attacks you. I'm being very specific here, not enemies attack you, only ever one enemy is going to attack the player. And to be fair, you attack one enemy, right? You've got a gun, you can only fire at one enemy at a time, but maybe in the future you might want to break this down to simulate, area of effect. Enemy attacks you, and then this probably just goes back and forth until one side is dead. And to simulate that, you attack enemy. If you've got no enemy to attack, you have survived, right? And if the enemy has nothing to attack, it means it's killed you, so you have been killed. All right. So we can now simulate this with scripts. So we come to encounter enemies. How many enemies? Let's say we do g.enemy count. We do 2 enemies, right? How much health does each enemy have? I'm going to do enemy health they also start with 100, right? How likely is an enemy to aim at you? Let's say they have a 35% chance, so 0.35, that's a 35% chance to aim at you. G.player aim, how much, how likely is the player to hit them? Well, that's a big open question. For this, I'm going to do 50%. So we've set up all our sort of state variables, attack enemy. So what we're going to do is we're going to do self hits. Did we hit or not? Well, that's just going to be random less than G.player aim, right? So if we did hit them, remember we did 0.5 here, it's 50% chance to hit. Bearing in mind, if you wanted, you could also model this graph in a different way. Here I'm doing the randomness within the script. I could, if I delete these edges, I could say like attack enemy, hit enemy, right? Miss enemy. And then enemy attacks you, hit player, miss player, right? And then I could put in these wait scripts what the chances to hit. So wait script is G.player aim. And this one would be 1 minus G.player aim. And maybe this is a better way to do it. So hit player, that is G.enemy aim, and missing player would be 1 minus G.enemy aim. And they would let's see how we can organize this graph. I think once you've hit an enemy, they then get to counterattack. If you miss, they get to a counterattack. If they hit you, that comes back there. So it is a little bit messy, but I think you can make that look not too shabby if we did it like this, right? That means we don't need to do that here. So if you hit the enemy, we also need weapon damage, right? G.player damage. Let's say their weapon does 25 damage per shot, which means you need to shoot the enemy 4 times to kill them. So what we'll do is we'll do the enemy health minus equals player damage. If you miss the enemy, nothing happens. And then we also need to do like G.enemy damage. How much damage do they do? Maybe less. They do 15. So they have to hit you much more to actually kill you. So when they hit the player, we'll do G.health minus equals enemy damage. And I think this killed comes off if the player was hit, right? And this survived comes off if you hit the enemy. There we go, that looks a bit better. So we can sort of simulate this now. We come here, we attack enemy, we roll the dice. Right now it's half and half, right? Because we set that player aim to 0.5. If I had set that to say 0.25, right? We come here, you see this is a 25% chance and this is a 75% chance, right? And so we roll the dice, we miss, they hit, and we were killed because we started at 0 health. But we'll solve that problem in a bit. Tell you what, we'll solve that now. So this is a subgraph, and so we could just you know, we could say player is already in the level, and we could just come up with a bunch of numbers, you know, player dot max health is equal to 150, and their health is equal to the max health. And so we start from here, right? And we go play, 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 and then we start. Oh, our logic for hit enemy is wrong, actually. We don't want to. We only want to go up to survived if the enemy count is equal to 0. Same with killed, right? Our player should only go to killed if their health is less than or equal to 0. So if we hit the enemy, enemy health. So if the enemy health is less or equal to 0, we need to put this into an if. We're then going to say g.enemy count. We're going to decrease the number of enemies, and we're going to reset enemy health back to 100. Because we're only dealing with one enemy, so it's almost like the enemies are in a queue and you attack one and then the next one comes. That's pretty much how video game combat works anyway. So this, and now we can actually start rolling the dice on these. They miss, I miss, they miss, I miss, they hit, I miss, right? I think 75% chance of missing is probably unlikely, so I'm going to bump this back up to 5. What we can actually simulate here is probably what actually happens is every time a player hits an enemy, because of the way human reinforcement learning works, our chances of hitting in the future improves, right? That's how humans and AI learn. So what we're going to do is, when we hit an enemy, I'm also just going to ever so slightly increase the chance of the player aim. Like, not by much, maybe like by 0.01. But every time we're hitting, the player is sort of learning and improving in their aiming skill. So here you go. So random, we miss, miss, hit, they miss, we hit, they miss, we hit. So how many enemies? Enemies are still 2 enemies, but they're currently on 15. They miss, we miss, we hit again, and eventually we should get to a survived or killed outcome. Is this working? What did we set player damage to? 25. Enemy health is 50 at the moment. And you know, it would be nice actually to watch this, right? So we'll do enemy info, and then we'll say self.count equals g.enemy count, self.health equals g.enemy health, right? All right, there's one with 25. We miss, they miss, we miss, they miss, we hit, and now count is 0. And actually what we want to do is we want to disable this path back to enemy attacks you. So to do that, we just do g.enemy count is greater than 0 is when we do that. Same if the player hit, we do g.health is greater than 0 there. And then we come up here. So that's all well and good. And what would be nice is to play this out within the context of our core gameplay loop. So I'm going to get rid of this player and level. And I'm going to rename this node here combat start, right? And this is going to be our combat gameplay loop. And I'm going to show you the power of sort of nesting. Almost like one of those Russian dolls, right? So when we come to encounter enemy, I'm going to get rid of this line here. I'm going to do a thing called thread.push. And I'm going to pass in the name of combat start. And then I need to also tell which thread or player is going to sort of be pushed and to play this. And in order to know what that is called, we just use the variable thread ID, lowercase, but the I is capital, snake case, that's called. So what this is going to do, and I'll show you. All right, so what we're going to do to test this, I'm just going to simplify this. Enemy count, there's only going to be one enemy with 50 health. And we're going to hit start game, enter level, explore, and then we come to encounter enemies where we did thread.push. It's going to come over to this node that we said, run combat start. And you see it's connected by this sort of purple line back to encounter enemies. And again, think of this like you've gone one level into the Russian doll. And then eventually when we finish this combat gameplay loop, we're going to do a thread.pop, which takes us one level back out of the Russian doll. And that's how we can sort of do nested gameplay loops. And so to do that, we need to go to both survived and killed, and we need to do, thread.pop and pass in that thread ID. Same here. And now if we follow this combat, we've missed that time. Come on. We can do this. I mean, again, we don't always have to press the button. The dice, I can, I want to simulate hitting the enemy, and that's what we do. I'm going to simulate them missing us. I'm going to hit them. And look, we survived. And now this has the thread.pop. So I click this, and it pops us all the way back to encounter enemies. And we can continue on our journey. We can now go ahead and claim loot. Okay, I think I've covered both the basics and quite advanced features of Strange Loops right now. So I'm going to leave it there. Hopefully, I think you get a feel for why this might be useful. It could be useful if you're doing sort of either a Metroidvania or even more linear type game, and you're sort of wanting to find soft locks in your progression system, or you just have a lot of interlocking systems in your sort of gameplay loops and you haven't built them all out yet. They're not all fleshed out in the prototype for you to actually playtest, and this is just a quick and dirty way to sort of get a vibe for that kind of thing. Whether this is useful as a communication tool, I probably personally won't use this myself for communicating ideas to, say, other members on a team working on the game. It might be useful, maybe if I improve this to make this sort of embeddable. If you could embed this into a document with a sort of a simplified UI, and it's sort of basically a graph that is interactive, that could be a useful form of communication, maybe. I'd be curious to hear other thoughts from other designers. Again, this is all on GitHub. I've put the link down in the description. I want you to think of this more as an idea than a product. Feel free to fork that project and, just hack it to parts and make it your own. It's fairly simple, very minimal dependencies. But yeah, hopefully it's useful to someone out there. If not, at least I find it useful to me. So there we go. Thank you for watching.